Now, when I have a more complicated expression than just x inside parentheses, my first step is different. Now my first step is to take the square root. This makes sense when I think through my order of operations. I have x, I add 3, and then I square that whole thing. So when I'm using inverse operations, the first thing that I need to do is undo the squaring by taking the square root of both sides of my equation. So x plus 3 and then squared. First thing I need to do is undo the squaring with square roots. When I take the square root of x plus 3 squared, what I'm left with is just x plus 3, whatever's inside that parentheses. When I take the square root of 100, I need to remember that there are two solutions. I have both 10 and negative 10, which sometimes we write as plus or minus 10. There are two different solutions here, but I am not done. I need to write two different equations, one for the positive root and one for the negative root. So I'm going to need to solve both of these equations, x plus 3 equals 10, as well as x plus 3 equals negative 10, one corresponding to the positive square root of 100, one corresponding to the negative square root. Using inverse operations, minus 3, I get my first solution, which is x equals 7. If you were just guessing checking, this is the one you would think of. 7 plus 3 is 10. 10 squared is 100. The very, very most common mistake is to just say, okay, x equals 7 or negative 7. No, 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 no. This is totally different than the case where there aren't parentheses, where I do have the same number, one positive, one negative. When I solve this second equation, subtracting 3 from both sides, I get x equals negative 13, not negative 7. This makes sense when I check my answer. Negative 13 plus 3 equals negative 10, and negative 10 times negative 10 is 100. So these are my two solutions, x equals 7 and x equals negative 13. Just remember that when we have an expression inside parentheses, first I square root, I have two different solutions, and I need to write two different equations and then solve them. Last little bit. What does this say? If when I isolate x squared and I get a negative, then this is an example of no solution. So let's subtract 9 from both sides. I get x squared equals negative 5. Now if I get this case, an isolated x squared equal to a negative, I just stop and I write no solution. I don't try to take the square root of both sides of the equation. There is no value of x that will make this equation true. Nothing times itself equals negative 5. So when I isolate x squared and I get a negative, I say no solution.